This video is going to be on accuracy and precision and percent error. First thing, accuracy refers to how close the measured value is to an accepted value. So for example, the density of water, the accepted value for the density of water is 1.00 grams per milliliter. Okay, so if you get a number like 0.99 or 1.01, something very, very close to that number, that's very close to the accepted value. So that's an accurate measurement. The way to remember that is accepted and accuracy both start with ACC. Precision refers to how close a series of measurements are to one another. So say the density of water is 1.00. Let's say I go out and measure and I get 0.75 grams per milliliter, 0.74, 0.75, and 0.76. Those measurements are very precise because I'm getting the same answer over and over and over again, but they're not accurate because they're not very close to the accepted value. Okay, so again, precision means you're getting the same answer over and over and over again. That probably means something's wrong with your instrument or you're doing something wrong in your measurements, but accuracy means you're close to the accepted value. Another good example of that would be if we show in archery. So hitting the center would be very, very accurate. These measurements, all three of these arrows are hitting the same spot, so they're very precise, but they're not accurate because they're not hitting the center. These are both accurate because they're hitting the center, and precise because they're all in the same spot. These are not accurate because they're not in the center, and they're not precise because they're not all in the same spot. They're hitting different spots. Next thing is percent error, and there'll be lots of times throughout the year you have to calculate a percent error. And percent error is basically to see how far you are off from what you should have gotten from the accepted value. So if you're 10% off, that's sometimes a pretty small percent error. Obviously, you could be 100% off. If you're supposed to get an answer of 3, you get an answer of 6, you're 100% off from what you should have gotten. So it's how far you are off from what you should have gotten. And we get percent error by taking our error, how much we're off, divided by what the accepted value was, and then turning that into a percent. Okay, so it tells you up here how to get the percent error. So here's an example. Students doing an experiment to find the experimental density of alcohol. Experimentally they find that. The accepted value, what they should have gotten, was this amount. So they're not off by that far. Got 0.847, should have gotten 0.793. So our percent error, we subtract these two numbers, and always subtract the bigger one first. We just want to know how much we are off. Doesn't matter if we're above or below. Just want to know how much we are off. Divided by the accepted value, and the accepted is 0.793. So we always divide by what they should have gotten. Make sure you do your subtraction and hit equals, and then do your division. Okay, subtraction, hit equals, and then do your division. That answer I don't have. If it's 0.847 minus 0.793, again, make sure you hit enter or do this in parentheses and then divide by your accepted value. So you do that, you get 0.068. Again, that is not your percent. Okay, that's as a decimal, so you need to multiply that by 100 and move the decimal over 2 places equals 6.8%. So what that means is this number they got was 6.8% away from what they should have gotten. That's a pretty low percent error. Another problem here, some kids are figuring out how much time it takes something to hit the ground. They get 4.3 seconds. The accepted, what they should have gotten, was 4.19. So if we take a percent would be 4.3 minus 4.19 divided by the accepted. In this case, the 4.19 is the accepted. Again, make sure you do your subtraction first, and then make sure at the end you multiply by 100 to get it into a percent. I believe this one is about 2.9% or approximately. It's approximately a 3% error, I believe.